Hello, thanks for joining me today. We're going to factor polynomials, and this is where we do the hard ones. We're going to do factoring of polynomials where the coefficient of x squared, that number in front of x squared, is not 1. Okay, so if there's a number there that's greater than 1, or could be even less than 1, I suppose, then we're going to learn how to do that. Okay, so we're going to have something times x squared plus something times x plus something else. Remember that, let's just talk real briefly about kind of what the problem is. Remember that before, when we were factoring, if it was just x squared, then the first terms were x, and it was really easy. We just had to figure out what number to add to x in each position, in each binomial, to add up to b and multiply to c. But now there is we have a number in front of x, then we need to have some sort of coefficient in front of x here and here, and that's going to be much harder. Let's just say w and v. I don't know. This is we'll see here that it just gets really complicated, right? Because w times v, w v x squared, and then w times n x plus v times m x plus mn, and so then it's right. So there's just way too much stuff going on here to be able to figure this out in the factoring method. We just kind of factor the last number and then see which of those factors add up to the middle number. We have to factor the first number also, and then we have to multiply the factors together and see which pairs of factors multiplied by the other pair of factors adds up to the middle number, and that's too much going back and forth. So I'm going to show you a method that we can use that will work every time, and it will tell you for sure if this trinomial can be factored, and it will be based on the same process that we did with the easier problems. This is the process of factoring. So I actually stole this from somebody, and I don't know, it's been so long I don't even know who I stole it from, so I apologize to them. But I'm going to call this the 4-square method. If somebody else calls it something else, they're probably right and I'm wrong. But we're gonna draw a little set of boxes, 4 squares, and we're going to use those to help us to factor these trinomials. So I'm going to show you the method, but before I go any further, I want to point out 2 things. Number 1, this method that I'm going to use is based on the next step, step 5 of factoring, which is the factoring by grouping. So what this is a fancy way to factor by grouping, and if you would rather not draw boxes and you want to just skip to factoring by grouping, please recognize that you can watch the next video and learn how to factor by grouping, but you still need to go through the first half of the process that I'm going to show you here. So this is equivalent to factoring by grouping, number 1. Number 2, there is another method that's going around on Mr. YouTube that's based on doing this little X, and you write numbers here and here and here, and it's the factors, and you do some fancy calculations. I've not found that method helpful for me, and so I've not even tried to figure out how to use it, and I'm not going to show it here. But if you want to know a different method, then you can go search that one out yourself. Okay, so this is the 4-square method of factoring polynomials. Here are the steps. Step number 1, you're going to multiply the first coefficient of x squared and the constant term. So 5 times negative 3 is negative 15. And then, step number 2, we're going to do our same step that we did before. We're just going to find the factor pairs of 15 that add up to negative 14. Okay, so 15 is negative 1 times, oh no, did I make a mistake already? Let me see if I did. oh yeah, no I didn't. Negative 1 times 15, which adds up to 14. So now we can, like we could keep on going. I could go negative 3 times 5 and negative 5 times 3 and so on. But you can see that if negative 1 plus 15 is 14, then negative 15 plus 1 is negative 14. So there's the factor pair that's going to work. Okay, now let me draw my boxes here a little bit better, a little bit easier. Now I'm going to draw a nice big set of 4 boxes, 2 rows, 2 columns, and I'm going to fill these in. Here's what I'm going to do. I'm going to put in the, in fact I'll do this in blue. I'm going to put the first term, 5x squared, in the first box, 5x squared. And I'm going to put the last term, negative 3, in the last box, negative 3. And I'm going to take the middle term, negative 14x, and I'm going to break it into 2 terms. I'm going to break it into negative 15, oops, forgot the 5, the 1, negative 15x, and 1x, positive 1x. Okay, where did that come from? Well, from that negative 15 plus 1 equals negative 14, that middle term. So it's the 2 numbers that added together to give that middle term. And so I'm taking that middle term, I'm just taking it, breaking it down into the 2 numbers. Okay. Now, here's what we do. We're going to go back to our GCF. We're going to do GCF, and notice we've been kind of being lazy lately, and we haven't been looking at the GCF for our polynomials. That's okay, because we're just learning how to do these other methods. But I'm going to go back and do the GCF for each row in each column. So for the first row, 5x squared and x, the greatest common factor between those 2 terms is x. And for the second row, negative 15x and negative 3, the greatest common factor, what they have in common is negative 3. Now I'm going to do the same thing for the columns. The first column is 5x squared and negative 15x. They both have an x, but they both have a factor of 5, so 5x. For the second column, x and negative 3. Now, those have nothing in common. And what do you say when they have nothing in common? What do all pairs of numbers have in common when they have nothing else in common? Well, 1. They both have a 1, a factor of 1. And in fact, notice that even the negative is not common, right? There's a negative 3 and there's a positive x. So I'm not even going to take the negative. I'm just going to say positive 1. Now, here's my answers. My answers are 5x, I'll write it in red here, 5x plus 1, x minus 3. That's it. Okay. Piece of cake, right? You might want to just scratch your head and think through that a little bit. It was a bit of a process, but it's not that hard. Step 1, multiply the first coefficient and the last term, the constant term, together. Step number 2, do our factor pairs of that result. Do the factor pairs and find a pair of numbers that adds to the middle number, the middle coefficient. Step number 3, draw a little box and put the first term in the first box, last term in the last box, and the middle term is split up into those 2 numbers that add up to get that number, and those are your other 2 boxes. And of course, notice that they're both x's, right? They both have an x. Step number 4, do the GCF for each row and column in this 4x4 grid, and there's your answers. Let's do it again. And notice, maybe there would be a question here, how do I know to put the negative 15x in the bottom corner and the x, the positive x, in the top corner? it actually wouldn't have mattered. If I'd switched them around, then I would have ended up with 5x plus 1 here and x minus 3 here. So it wouldn't have mattered either way. Okay, let's do another one. Let's kind of clear our heads, shake our heads. We're going to do 6 of these, so that's 1. Let's try this again. I'll try doing my work in blue, and I'll just write the answers in red. So I'm going to do the first step, step number 1, 6 times negative 6 is negative 36. Okay, step number 2, factor pairs of negative 36. Well, negative 1 times 36, negative 2 times, what is that, 18, negative 3 times 12, negative 4 times 9, and I haven't been explicitly saying that I'm adding these up as I go along, but I am. I'm taking mental note. What is the sum? Right, and the sum is getting closer and closer to 5, and we finally found it. Negative 4 plus 9 is 5. So that's the pair of numbers that we're looking for. Okay, now I'm going to draw my little 4 boxes, 4 squares. When I was in grade school, 4 square was my favorite game. 6x squared, negative 6, so the first term in the first square, the last term in the last square, and in the other 2 diagonal squares, we'll write negative 4x and positive 9x, because those 2 add up to that middle term, 5x. Now we're going to do the GCF for each row and each column. 6x squared plus 9, and positive 9x have a 3x in common. Negative 4x and negative 6. Notice they have a negative in common, and they're both even, so a 2 in common, but that's it. 2 times 2, 2 times 3, there's an x, and they're both negative. Okay, so then 6x squared and negative 4x, well, those both have a 2 in common and an x in common. 2 times 3, 2 times 2. And then 9x and negative 6x, well, one's positive, one's negative, so I'm not going to say they have a negative in common, so I'll just say plus. But they do both have a 3 in common. So we think the answer is 3x minus 2 times 2x plus 3. And notice on the last one, I wanted you to kind of get a chance to kind of think about that last one and absorb what was going on. So I didn't put in the extra step of checking the work, but we probably should check our work on these. Not that there's any question. We know we're right. This process works 100% of the time. But just for your own, feeling good about this, let's do it. 3x times 2x is 6x squared. 3x times 3 is positive 9x. Negative 2 times 2x is negative 4x. And negative 2 times 3 is negative 6. 9x minus 4x is 5x, so we have 6x squared plus 5x minus 6. And that's what we started with, and so it worked. Okay, but again, the answer is 3x minus 2 is one factor. 2x plus 3 is the other factor. Order doesn't matter, so we could have done it in the other order. It would have been fine. All right. This is pretty cool, isn't it? Now, if you're feeling somewhat confident that you understand the steps, then try it yourself here and see what you can do. Hit pause. I'm going to keep on going. All right, so we'll take 4 times negative 5 is negative 20. The factors of negative 20 are negative 1 times 20, which is 19, negative 2 times 10, which is 8, negative 3, now that doesn't work, negative 4 times 5, which adds to 1. So there it is. Now I'm going to do my boxes, 4 squares. In the first square, upper left-hand corner, 4x squared. In the lower right-hand square, the constant term, -5. Break my x into two numbers, -4x and +5x. Common factor in the first row is x. Common factor in the second row is, well, they have nothing in common except that they're both negative, so -1. First column, the common factor is 4x. Both have a 4, they both have a 1x. Second column, the common factor is 5. One's positive, one's negative, so we just say +5. We don't say there's a common factor of -1. And so my factors are, in red, x minus 1, 4x plus 5. All right, let's try it again. The first coefficient is 3. The last constant, the constant term is 5. 3 times 5 is 15. The factors of positive 15 are 1 and 15, which if we add give us 16. So we hit it the first time. We didn't have to do any further work here. We'll draw our 4 squares. (3x squared) 5. Then we'll break that middle term 16 into 1x and 15x's. 15x plus 1x is 16x. There's our 1 and 15. The first row has a 3x in common. The second row has nothing in common, x and 5, so that we say +1. First column has an x in common, and the second column has that 5 in common, +5. 3x plus 1 times x plus 5. If you would like to hit pause and do the multiplication of those two binomials to check my work, and you're welcome to do it. Use the FOIL method. Now, these last two problems are going to be, I have a little trick to them. There's one little trick that you need to be aware of, and I should have mentioned this earlier. I'm going to do the same process. 10 and 3, 10 times 3 is 30. Now we want the factors of 30 that add up to -17, and there's the clue to the problem that we're going to face here. The factors of 30 that add up to -17, of course, are negative. So we're going to do -1 times 30, -30, which is -31, that doesn't work. -2 times -15, oh, that does work, -17, okay, there it is. So now I'll do my 4 squares. And we'll plug in 10x squared and 3. And then we're going to break that -17 into -2x and -15x. Now, again, let me point out that there's a negative here and there's a negative here. And when you multiply a negative times a negative, you get a positive. Okay, so the common factors going across, 10x squared, -15x. Well, the common factor is 5x. 5 times 2, 5 times 3. Okay, and then going across here, the common factor is, well, nothing, right? -2x, 3, nothing in common there, so it's just 1. here's the trick. Normally, I said that if they don't have a negative in common, then we just say it's plus 1. But in this case, where both the middle terms are negative, we need to think of it as a negative times a negative equals a positive, and so that 3 actually has a factor of 2 negatives in there. That 3 is made up of 2 negatives multiplied together to make it positive 3. So we're going to say when the two diagonals there, right, the two middle terms are both negative, then we're going to say then these are going to be minuses instead of pluses. Okay. You'll see, I think you'll see in just a minute. We'll check this one for sure. Okay, 10x squared minus 2x, so that's going to be a 2 for sure, and then an x. Now, since the first term is positive, we're going to just keep this be positive. But the second column, negative 15x and 3, obviously they have a 3 in common, and then we're going to say there's a negative in common because that 3 is made up of 2 negatives multiplied together. Okay. So there's my factors. My factors are 5x minus 1 and 2x minus 3. Okay, let's just multiply these out and just see if what I've been saying is true. So 5 times 2x is 10x squared. 5 times negative 3 is negative 15x. And negative 1 times 2x is negative 2x. And then negative 1 times 3 is positive 3. Negative 15x minus 2x is negative 17x. So this is what we started with. That's the original trinomial, so that's correct, which means that these factors are correct. But notice that we had to break one of the rules that we had established, where if they don't both have a negative, then we bring down a plus here. And the only time we break that rule is if they're both these are negative, then both factors are going to have a negative in them. Okay, does that make sense? I hope you're able to, that's not too big a deal. I want to point that out to you because that's that's the only little tiny trick in here in this method. Okay. Those people using the X method are probably laughing at me right now. That's okay. All right, let's do the last one. So the 2 and the 7. 2 times 7 is 14. So the factors of 14 are 1 times 14. Oh, wait a second. We're trying to get to negative 15, so it's going to be negative 1, negative 14 adds to negative 15. So that's it. There's our two numbers. So let's draw our 4 squares. Once again, notice we have that same situation where our two factors of 7 or 14, the two factors of positive 14, are both negative. So we're going to do 2x squared, 7, but then we're going to write negative 1x and negative 14x. And we'll do the factors. Well, there's a 2 and an x in common in the first row. Second row has nothing in common, but we're going to say negative 1 or minus 1. The first column has an x in common. The second column has a 7 in common, but we're going to go with negative. Again, because these two are both negative. So now there's our factors. 2x minus 1 and x minus 7. And that's it. That's how you work these problems. Thank you very much for watching, and have a great day.